Hello, everyone. I'm Mohammad Asif Khan. I'm a research scientist at Qatar Mobility Innovation Center. I'm presenting my work on multimodal crowd counting with Pix2Pix GANs. And my co-authors in this work include Dr. Hamid Munawar and Professor Rida Hamila. Well, crowd counting is an interesting problem in computer vision with many real-world applications. Traditionally, visual crowd counting uses color or RGB images to estimate crowd densities. However, using RGB images alone can get a poor performance, especially when there is poor illumination or dense crowds or bad weather conditions like fog or rain, etc. So to cope with this challenge, researchers have proposed multimodal models that can learn from both color and thermal images, which are taken from, which are captured using thermal infrared cameras. So using two different modes like RGB and thermal images, multimodal models can achieve better performance and better accuracies. However, thermal images are not always available beforehand. So in this work, we are actually addressing this specific problem. We propose a Pix2Pix GAN network to generate thermal images from RGB images and then use a multimodal CNN model, which we named MMCount in this paper for crowd density estimation and counting to get the maximum accuracy using RGB images alone, because thermal images are generated using the Pix2Pix GAN from the color images, and then we use the original color images and the generated thermal images in the multimodal architecture to estimate the crowd density in this work. So here's just a summary of some of the very well-known crowd counting architectures proposed over the last couple of years. In 2015, Crowd CNN was proposed, which was the first CNN model using density estimation method for crowd counting. It was a single column and very simple architecture. Then over the next couple of years, there were different innovations in the model architectures like multi-column using transfer learning, the pyramid structure in 2018 and SANET. Then encoder, decoder, and other pyramid structures were proposed over the course of time to improve the performance on benchmark data sets. However, all these models just show innovation in the model architecture to improve performance over the benchmark data sets using single model RGB images only. Now, and then generative adversarial networks are GANs, which were first introduced by Goodfellow in 2014. And then over the course of time, different variants of GANs have been proposed, like conditional GANs were proposed to generate specific types of data by providing some specific conditional information about the data being used to train the model. Then DC GANs was introduced to further improve the performance of GANs to improve more realistic images. Cycle GANs was proposed in case when the pair images are not available before training. So cycle GAN can get trained without pair images. Then a Pix2Pix GAN was introduced for domain translation, where image from one source domain can be translated into an image in the target domain. Style GAN was proposed later on to generate more realistic and diverse images. Pix2Pix GAN especially has been recently applied to generate synthetic near-infrared images of crops, lung CT scan images, and MRA images of brain, etc. So this is one of the popular GAN model to generate images in a target domain. This slide shows some details about the Pix2Pix GANs. So here you can see in this figure the architecture, just a very generic architecture of Pix2Pix GAN, which consists of a generator and a discriminator network. is denoted here by G, the generator, and D, the discriminator. So the generator take label images of label images X and Y, which are the input images, and Y is the label, to predict the to generate synthetic labels for the images X. And then the discriminator network actually discriminate between the actual target, between the actual label, which is Y, and the generated label produced by the generator. So it classifies the generator output, whether it's real or fake. And the end goal of the whole architecture of the Pix2Pix is to make the generator output as realistic as possible, which is the desired criteria for the Pix2Pix GAN. This slide shows the proposed architecture with the Pix2Pix GAN and the integrated crowd model in a work for crowd density estimation or some benchmark data sets. So as you can see here, we use RGB images and real thermal images captured from thermal cameras to train a generator. The generator, once trained, it produces thermal images for any RGB images that is fit to the generator. And then the crowd model can use the generator output, which is a thermal image, and the actual image, which is the RGB image. So the crowd model, which is actually a multimodal crowd architecture, can use two inputs, the RGB, the original RGB image, and the generated thermal image generated by the Pix2Pix GAN, by actually the generator of the Pix2Pix GAN, to estimate the crowd density inside the RGB image. This is the architecture of the crowd model, the multimodal crowd model, which we call count in this image, which can consist of convolutional layer with some pooling layers, and then at the end there is a fusion layer with just fuse the two layers which are taking two inputs, RGB and TIRs. And then at the end, there is a regressor which just estimate the density map for the image. We conducted experiments using 3 different data sets, drone RGBT, Shanghai Tech, and CAR PK data set. We used 2 evaluation metrics, mean absolute error and grid average mean absolute error, GAM. These are 2 of the most widely used method for estimating the crowd density and has been used thoroughly in many recent publications. We evaluated the proposed model and compared the results. Were 5 baseline models: MCNN, CMTL, CSRNet, SANET, and LCDNet. All these models vary from each other in different aspects, like MCNN and CMTL are multi-column architectures. CSRNet is a single column, but it uses transfer learning from VGG16. SANET is another model for crowd, and LCDNet is one of the extremely lightweight model. SANET is also lightweight, but LCDNet is extremely lightweight model proposed recently. For training purpose, we use a Lambda server with 2 RTX 8000 GPUs, and we use PyTorch framework for training. The slide shows the results for the Pix2Pix GAN. So we first trained again a Pix2Pix GAN model with paired images, and we only had 1 dataset available with paired images of RGB and thermal images, and this dataset is drone RGBT dataset. So we trained the Pix2Pix GAN on drone RGBT dataset to generate thermal images. And here are the results. So this table shows the mean absolute error when the model was trained on RGB image, and when the model was trained on real thermal images, and when the model was trained on the generated thermal images. And here you can see the mean absolute error for the generated thermal images. The difference between the thermal and the generated thermal images actually you can see the error being the error being occurred in the Pix2Pix GAN, because these images are not real. These are generators' outputs. And then this slide shows the performance of the whole architecture, the count with Pix2Pix GAN to generate the thermal images. So the evaluations was carried out on 3 data sets: drone, RGBT, Shanghai Tech Part B, and car PK. And 3 different crowd architectures were used in this comparison: MCNN, DroneNet, and count. And here you can see, like, when the model was trained on RGB images alone, and when the model was trained on thermal infrared images alone, and when the model was trained using multimodal a multimodal method like RGB and thermal images both. So the accuracy difference is very obvious here. You can see that the RGB and TIR, the multimodal architectures, has always lower mean absolute error and game values for all the 3 models on all the data sets. The difference might be lower in some cases and higher in some cases, but there is always some level of improvement in the performance. Now, here are the discussions and some of the conclusions from these experiments. So the first one, that RGB only images produce a higher counting accuracy than thermal only images, because the RGB images has always more enriched information. So this is obvious, and this was expected results what we got in the results in the previous table. However, when we use RGB along with thermal images, which were our generators output actually, we can achieve better accuracy than the RGB only images. And even this accuracy was pretty close to the RGB plus original thermal images being used, which supports the idea or the motivation of this paper that we can use Pix2Pix GAN to generate thermal images to train multimodal crowd models, and which can be later used in some of the scenarios where the crowd images are not clear due to weather effects or due to lightning effects. So this supports the idea of the paper. At the future work, we aim to extend our evaluation to train the Pix2Pix GAN on images of more correlated scenarios, just to further confirm the benefits that we achieved in this analysis or these experiments. We also aim to try other GAN models to see how much performance gain we can get using those models. Especially the cyclic GAN, we are more interested to try the cycle GAN, because in Pix2Pix GAN we are always bound to use. I mean, we always need to the data sets with paired images. However, with cycle GANs, we don't need paired images data sets, so we can train the model using unpaired images as well. So we are interested to try those GAN models. And third one, we really are interested to design lightweight GAN architectures, because the multimodal architecture for crowd, of course, when we use multimodal, we use, let's say, kind of multiple columns in the CNN architecture, which increases the complexity or the overall runtime of the inference model. So we aim to design lightweight GAN architectures so that the inference time of the crowd model can be reduced as much as possible, and it can support real-time applications as well. So that's all, and thank you so much. If there is any question, please feel free to write to us.